in this problem we have an open top cylinder. We want to find the dimensions that create the minimum surface area required to still make 24 centimeters cubed to be the volume. Now, in order to do this, we need to first put h in terms of r. So we'll start out with the volume equation, pi r squared h. Then we'll substitute in the value we have for volume. Then we'll divide both sides by pi r squared. So that gives us our h in terms of r. So we can go ahead and plug that in our surface area equation. So that way we only have one variable. So in this, so what you can do is that 2 pi r, so you combine these together, but since you're multiplying these two fractions, the pi r on the top and bottom So in this problem we have an open top cylinder that we want to find the dimensions that create the minimum surface area that still produces the 24 centimeters cubed as the volume. Now, in order to do this, in the surface area equation for an open top cylinder, we want to get h in terms of r, because we can only work this if we have one variable. And if we get h in terms of r, it'll combine nicely. So we need to start out with the volume equation. Next plug in the value we have for volume in, and then we just divide both sides by pi r squared, and that gives us our h in terms of r. So we can plug that in our surface area equation, and so in combining the 2 pi r and the 24 divided by pi r squared, we can think of it as 2 pi r over 1. So the pi and one of the r's will cancel out with each other, and the 2 will multiply by 24. So you get 48 over r. So, and then we can rewrite 48 over r as 48r to the negative first, just to make the product rule a little easier. So we go ahead and take the derivative. SA prime equals 2 pi r minus 48r negative 2. Let's put that r to the negative 2 in the denominator, so it's r squared, because it'll make it a little easier in the next step. So in this step we butterflied. So you butterfly with 2 pi r times r squared is 2 pi r cubed, minus, keep the symbol, minus 48 times 1, which is just 48. All that over r squared times 1, which is just r squared. So we'll just take the numerator and make that equal to 0. We don't need to worry about the bottom. And then it becomes a basic algebra problem. 48 equals 2 pi r cubed. 24 equals pi r cubed. And then 24 over pi equals r cubed. We'll just take the cube root of each of them and get 1.969 centimeters equals r. So we can take that r value and just plug it right into the equation we have for h, and we'll get 24 divided by pi times 1.969 squared, and that equals 1.969 centimeters. So your dimensions for the cylinder are radius and height being the same. That gives you your smallest surface area possible with the volume of 24 centimeters cubed.